Welcome back, class. Let's take a look today at simplifying radicals. So we know by now that a radical is something that looks like this, and there's usually some combination of numbers or variables or several terms underneath this. We would call this a square root since there's no number here. If you don't see a number written in that, I'm going to just write x to the fifth in. If you don't see a number written up here, then we know that that is just going to be a square root. So we would say this as the square root of x to the fifth power. If we look at something like this, it looks very similar, but instead of a 2 up here, which is unwritten, we actually have a 3, so that would be the cube root of x to the fifth power. You might see something that's crazy looking though, like a 5. You could call that the fifth root of x to the fifth power. There's no fancy name after cube root. It's just fourth root, fifth root, etc. So the question is, how do we simplify these things? And it works differently if you have a square root or a cube root or a fifth root, but in another way, it all works the same way. Let's take a look at an example here. And we're going to use these examples from your notes. So, square root of 320. When we're doing a square root of 320, basically what we're doing is we're looking for groups of 2. And I'm going to write that down. For groups of 2. And the reason we're looking for groups of 2 is because our root number here is 2. Okay? Now, this might seem kind of funny looking for groups of 2, but I only have a single number here. What we're going to want to do with this 320 is break it down into its prime factorization. If you remember from elementary school, you probably talked about prime factorization, taking a number and doing a factor tree, where you can break this down into 2 times 2 times 2 times whatever will give you 320. The way I always do this is I start with 2's, and I take this number here and I divide it by 2. So I would get that as 2 times 160. All right, so 2 is a prime number, 160 is not prime, so let's see if we can divide that by 2 again. And we can, that's 2 times 80. 80 is 2 times 40. 40 is 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. And now we've got all prime numbers. So our prime factorization of the square root of 320 would look like this. 2 times 2 times 2 times 2 times 2 times 2 times 5. So that's 1, 2, 3, 4, 5, 6 2's. Let me count them. 1, 2, 3, 4, 5, 6 2's times 5. And we notice all that's still under the radical here. The next thing we're going to want to do is, like we said, look for groups of 2. So right here, I've got a group of 2 numbers that match. Here, I've got a group of 2 numbers that match. Here, I've got a group of 2 numbers that match. So class, how many times did we circle these groups of 2? We did that 1, 2, 3 times. Let's pull 3 2's out front. What didn't have a group of 2? Well, we just had a single 5 hanging out here. So that, whatever is left over, whatever doesn't have a pair or a group of 2, and we're not talking about the number 2, we're talking about 2 numbers, has to stay under the radical. Now this is not a great final answer. We would want to go ahead and multiply 2 times 2 times 2 would give us 8. And 8 square root of 5 would be how we simplify the square root of 320. Now, if you put the square root of 320 in your calculator, you're going to get some messy decimal. But you should get that same messy decimal if you type in 8 square root of 5. This would be the exact value, though. That decimal would be rounded off at some point. Let's do another one. Here, instead of looking for groups of 2, since our root number is 3, we're going to look for groups of 3. And I'm going to write because root number is 3. Okay? So let's go ahead and do a prime factorization here. So that'd be 2 times 128. 128 would be 2 times 64. 64 would be 2 times 32. 32 would be 2 times 16. 16 would be 2 times 8. 8 would be 2 times 4. And 4 would be 2 times 2. Now, we see that we've written this with a string of 2's. We've got 1, 2, 3, 4, 5, 6, 7, 8 2's written here, okay? And I'm going to show you a shortcut instead of writing all this out. We could rewrite the cube root of 252 as, we said there were 8 2's. We could rewrite that as the cube root of 2 to the 8th power. We know that we can shorten 2 times 2 times 2 times 2 8 times as 2 to the 8th power. Now here's where this gets really quick. Okay? Ask yourself, how many times does 3 go into 8? Well, 3 goes into 8 twice, right? So we're going to pull out this 2 twice. Now, what's our remainder if we divide 3 into 8? We know our remainder would be 2. So we'd have 2 under the square root, or under, sorry, the cube root. We'd have that in there twice. So our final answer, if we do this multiplication, would be 4 times the cube root of 4. Let's do one more of those. Our next example is looking like the cube root of 48. Let's go ahead and do a prime factorization of 48. That'd be 2 times 24. That would be 2 times 12. That would be 2 times 6. And that would be 2 times 3. So if we want to rewrite this in exponent form, we'd have the cube root of 2 to the 1, 2, 3, 4 power multiplied by 3. And we can do the exact same thing we did before. How many times, or if we divide 3 into this exponent here, how many times does that go? It goes once. So you can pull 1, 2 out. And then what's our remainder with that? If we divide 4 by 3, we get a remainder of 1. So that means we have 2 to the first power under the square root, or under the cube root here. Now let's look at this 3. There's no other 3's in here, so we'd say that's 3 to the first power. Can you divide 3 into 1? No, you can't. If you tried, you just get a remainder of 3. So the 3 to the first power has to stay under the cube root. So outside we have a 2. Under the cube root, we've got 2 times 3, which is 6. Good. This gets interesting when we have some type of variable under the radical as well. So here we've got the square root of 256 times x to the 4th, y to the 4th. Now I'm going to do a little bit of mental math here because I know that 256, if I start breaking that down, I could look at something like 2 times 128, and I could look at that as 2 times 64. But I know 64 is a perfect square already, okay? So 64 I would say is 8 times 8. So here what I've done is I've shortened this up a little bit, okay? And I can rewrite this in exponent form. So since my root number is 2, I can go ahead and rewrite this as 2 squared times 8 squared. This saves me a lot of time in working my factor tree. But also I'm kind of working smart here because if my root number is 2, I'm looking to divide these exponents by 2. Well, since my exponents are both 2, that makes my process a little bit easier. I've also got x to the 4th times y to the 4th under the radical as well. So I'm going to divide this root number of 2 into this, and I know that that would happen one time, so I can pull 1, 2 out. Also, if I take this root number into this 2, I would get that happening one time, so I can pull an 8 out. Let's look at the rest of the square root now. And you can do this in one step, but we've not seen a variable yet. So variables are going to work the same way that the numbers worked, right? We've got a root number of 2 and x to the 4th. So x to the 4th is just the same thing as x times x times x times x. So if we looked at this, we'd say, okay, here's a group of x's and here's another group of x's. So we'd pull out 2 group of x's, or we'd pull out x times x. So here we could say that would be 2 times 8, times x times x. And then y would be the same thing. It'd be y times y times y times y. And we're looking for groups of 2. So we could pull out 2 y's. And we've pulled out everything underneath that radical now. Last thing we'd want to do is clean this up a little bit. 2 times 8 we know is 16. X times x is x squared. Y times y is y squared. And that is the simplified version. Last but not least, let's take a look at the square root of 16 a cubed b cubed. Now, we should know that the square root of 16 is 4, so let's go ahead and write that. And then under the square root, we still have a cubed times b cubed. Okay? You could do this all in one step, but I want to break it down into little pieces for you. Okay? So, if we divide our root number of 2 into 3, we know that that happens once, so we could pull out 1a, but we'd have 1 left over. So we could rewrite that as 4a, and then under the radical, we'd still have an a living under there. And then b cubed is b times b times b. If you divide the root number of 2 into 3, you get 1 with a remainder of 1. So we can pull out 1b, and we can leave our remainder b in here. This is simplified. On the next page, you have some practice, which you have 10 problems for practice on simplifying square roots. Good luck with that. Let me know if you have any questions.